Welcome to This Explainer. Okay, today we are literally unlocking the insider cheat codes to mastering top-tier tech interviews. Whether you're gunning for an AI engineering role or a senior data scientist position, I'm here to tell you that technical brilliance alone, it just won't cut it anymore. You really need a strategic mindset. You've got to prove that you can connect those complex algorithms directly to real-world business value. And that is exactly what we're going to decode together today.
So here's our game plan. We're going to tackle 5 core pillars: AI engineering core concepts, navigating metrics and experiments, proving cause and effect, governing data at scale, and finally, communicating like an executive. Let's just jump right in.
All right, Section 1, AI engineering core concepts. We're moving from just throwing around jargon to actual real-world production.
Okay, so if you're out there interviewing right now, you absolutely cannot just parrot textbook definitions for things like RAG. Interviewers want the gritty production reality. Don't just tell them that retrieval-augmented generation bridges models with external databases. You need to explain exactly how you'd use it to eliminate hallucinations and how it grounds your model's answers in verifiable, totally up-to-date enterprise logic.
And you know, the exact same thing goes for AI agents. A junior candidate, they're going to say an agent is just an LLM that uses some tools. But you need to explain the reasoning loop. Show them you understand that an agent utilizes memory and APIs not just to tell a user how to book a flight, but to autonomously go out and execute that booking.
Which brings us to, honestly, the exact kind of terrifying scenario a skeptical tech exec is going to throw right at you. Picture this. Your AI agent just deleted a production database. How do you prevent irreversible actions? Oof. Yeah, they want to see if you really grasp the stakes of unleashing autonomous systems into the wild.
So here is your crisp executive bottom line answer. You don't blame the model, you blame the architecture. You tell them you prevent this by building absolute rock-solid guardrails. You implement human-in-the-loop patterns for any high-risk operations. You make sure the agent only ever executes code in a sandbox environment. You set strict token and financial budget limits so you don't end up in infinite loops. And most importantly, you simply never give the agent access to destructive tools in its context to begin with.
Moving right along to Section 2, navigating metrics and experiments. This is all about avoiding the classic metric divergence trap.
Let's pivot over to product analytics. Imagine you're sitting in the interview, and they slide this scenario across the table. You ran an A/B test for a new recommendation algorithm. Clicks are up 3%, but revenue is totally flat. What do? It's the ultimate metric divergence trap. They're testing to see if you immediately jump to a random conclusion or if you actually investigate the underlying mechanism.
To solve this, you'd want to build out a diagnostic dashboard to really drill into the deltas. Yes, the click-through rate is up that 3%, but if you look closer, the average item value clicked is actually down 13%. Users are buying more items per order, sure, but they're buying way cheaper items. This is the smoking gun that proves the new algorithm is driving volume, but definitely not value. It's generating curiosity clicks, not true purchase intent clicks. This ties directly into how you have to design metrics for really fuzzy concepts like, say, user satisfaction with an AI feature. You just can't rely on a single number. You need a layered approach. First, your primary metric is task success rate. Did the user actually accomplish what they set out to do? Second, you need secondary metrics acting as quality signals, things like explicit feedback or how often they hit regenerate. And third, guardrail metrics, where you're actively watching for harm through error rates or a sudden spike in support tickets.
All right, Section 3, proving cause and effect. Time to put on the skeptic's lens.
So, you've got your metrics dialed in, but how do you prove your shiny new feature actually caused those numbers to move? Because in the real business world, stakeholders desperately want to claim causation. The interviewer is going to ask, hey, marketing ran a campaign and sales went up 15%. Did we cause that? This is the correlation versus causation debate in its absolute purest form.
You've got to tackle this by evaluating the hierarchy of causal evidence. The whole goal is to estimate the counterfactual. What would have happened without that campaign anyway? Level 1 is your gold standard, a randomized A/B test. Now, if you can't get that, you drop to Level 2, a natural experiment, using pseudo-random variation like a staggered rollout. Level 3 is observational matching, where you compare statistically similar groups. And Level 4, well, that's what marketing is usually doing, a simple before and after. You must explain to the interviewer that this is literally the weakest form of evidence.
Next up, Section 4, governing data at scale. The classic avoiding garbage in, garbage out scenario.
Because, let's be real here, none of your brilliant experiments or complex models matter even a little bit if the data feeding them is totally broken. This is a massive scale operational challenge. The prompt is, your data lake is petabytes large, but bad data is causing model failures. How do you govern this? Now, the trap here is suggesting you'd use manual reviews or just write some one-off scripts.
The right approach here is all about architecture. Look, data quality at a massive scale isn't about perfection. It's about systematic identification and automated remediation. You need automated schema validation running constantly to catch missing prices. You need automated uniqueness checks that immediately trigger deduplication pipelines. You don't try to fix the data by hand. You build automated circuit breakers that physically stop bad data from reaching the models in the first place.
Which brings us to our fifth and final section, communicating like an executive, the art of data storytelling.
We've arrived at arguably the most critical pillar of all. Here's the setup. You've got nuanced findings, some good, some bad. The executive wants a recommendation in exactly 5 minutes. How are you handling this? This is where your technical brilliance absolutely must pair with ruthless clarity.
To completely ace this, you deploy what's called the pyramid principle. Look, nobody cares about your methodology until they actually trust your conclusion. So you spend the first 30 seconds delivering the bottom line, your exact recommendation, and the expected outcome. Then you take 3 minutes strictly presenting your top supporting points and, crucially, your confidence level. Finally, you spend 1.5 minutes on the "it depends" phase, acknowledging the main uncertainties and proposing concrete next steps.
Think about the difference here. When you're faced with that kind of nuance, whatever you do, don't get defensive. Don't start rambling with, it's complicated, there are a lot of factors, results really vary by segment. Honestly, that just makes it sound like you have no idea what's going on. Instead, confidently say, I recommend X, it's strongest for segment A. For segment B, we're going to watch it and potentially adjust. That kind of conditional recommendation shows you completely grasp the nuance, but you still have the leadership to make a decision.
Which leads right into the ultimate takeaway for literally anyone sitting in a data science or AI engineering interview. You are paid to have judgment, not just to present data. Building the model, that's really only half the job. Translating that mathematical reality into strategic business decisions is the real reason you are in the room. So I really want to leave you with a thought to chew on. In a world where AI can effortlessly generate the code and run the models for us, will your strategic judgment be your ultimate competitive advantage? Keep that front of mind for your next interview. Thanks so much for joining me on this explainer, and I'll catch you next time.